book, so refer as CV, velocity factor, right? So these are the basic terms which we need for calculation of Levi's form factor, okay, and calculation of Buckingham's equation, or that is the dynamic load and the beam strength and the wear strength. Okay, so we will see the design of this in the next class, how to find out the module by using the this Levi's form factor formula, and how to calculate for the next design strength, wear strength and the beam strength. Okay, so we'll see it in the next class. Thank you.
Good morning, everyone. In the last class, we had started with the 2D transformation, how the transformation is used to orient the different objects, shapes and all. So in that we have started with the translation, where an object has to be displaced from one position to the other position in the straight line. So in that case, if an object consisting of 4 points, we need to displace all the 4 points with respect to x and y axis to get the new coordinates. Next we started with the rotation. So in the rotation we had 2 cases. One is if an object is rotated clockwise and if it is rotated in an anti-clockwise. So we wrote the x dash y dash coordinates, the new coordinates with respect to the old coordinates as cos theta, sin theta, minus sin theta, cos theta. Okay, and these are the original coordinates. So in case of anti-clockwise, we wrote it as x dash y dash cos theta minus sin theta, cos theta. So these are the difference between these 2 orientations. If I rotate an object clockwise, I have to use this equation to find out the new coordinates. If I want to rotate the object anti-clockwise, the coordinates of the new location will be calculated through this particular equation. Okay. Okay, so we will try to analyze this particular case with the help of an problem. So I'll take a triangle, rotate a triangle having coordinates. So these are the coordinates. One is 0, 0, 1, 0, and 1, 1 by an angle theta is equal to 90 degree. Okay, 90 degree anti-clockwise direction. So we need to observe the direction through which it is being rotated, whether it is an anti-clockwise or a clockwise, because there is a slight difference in the, or the slight variation in the equations which we have formulated. So for clockwise and for anti-clockwise we will be having two different equations. So in the problem definition they will be giving you the direction with which it is being rotated, whether it is a counterclockwise or a clockwise rotation. So from the problem definition we can see that a triangle having a coordinates, three coordinates they have been given. It has to be rotated by an angle 90 degree anti-clockwise direction. So if I try to plot this particular triangle, so first we'll plot this. So this will be the origin 0, 0, and I'll take this as first, second, third, 1, 2, 3. Okay, so first will be the origin. The first will be the origin. So first point is at the origin. This is the first point. The second is at 1, 0. 1, 0 is, this is the second point. The third point is 1, 1. This is the third point. Okay. So if I draw a triangle, it looks like this. This is the triangle which we can see here. So this triangle has to be rotated by an angle 90 degree anti-clockwise direction. Okay, so it has to be rotated anti-clockwise. Okay, so this is the figure before rotation. So now we need to find out what will be the location of these 3 points after it is being rotated by an angle 90 degree anti-clockwise direction. So if you see the particular equation, for a particular equation we have, for an anti-clockwise we have an equation x dash y dash is, you see that cos theta minus sin theta cos theta x y. Okay, so we know that the theta is 90 degree, so sin 90 will be 1, cos 90 will be 0. Okay, so because the theta given is 90 degree, so we will be doing with respect to that theta, cos 90 is 0 and sin 90 is 1. So if I consider the first point 0, 0. Okay, this is the first point 0, 0. So if I apply for this, so its new coordinate x dash y dash will be, so first is cos 90, this will be 1, cos 90, this is 0, minus 1, 1, 0. This is the rotation matrix. Okay, and the original coordinates are 0, 0. So if I multiply them, okay, cross multiply, 0 into 0 is 0 plus 1 into 0 is 0. So the original coordinates will be, first coordinates will be 0, 0. There will not be any change in the coordinate system, because as it is rotated from this particular point, okay, so the origin will remain as it is. One of the coordinates will remain as it is. So if I go with the second point, that is 1 comma 0, the second point is 1 comma 0, so it will be x dash y dash will be 0 minus 1 1 0, and the coordinates are 1 and 0, 1 and 0. So if we cross multiply that, so 0 into 0 is 0, minus 1 into 0 is 0, so we'll be getting 0 as an coordinate, 1 into 1 is 1, so 0 comma 1 will be your second coordinate, x dash y dash. So this will be your second coordinate, which means that here the shift was from 0 comma 0, the shift was same as 0 comma 0. Here the shift from 1 comma 0 is taken to 0 comma 1. Okay, so next we will be doing the next one, that is 1 comma 1. So 1 comma 1. So x dash y dash will be equal to 0 minus 1 1 0, and here will be 1 1. Okay, so calculate what you will get. So 0 into 0 is 0, minus 1 into 1 is minus 1, so we will be getting it as minus 1, 1 into 1 is 1, 1 into 0 into 1 is 0, so we will be getting it as 1. So this will be x dash y dash. So if you see this particular case, you can conclude that from 1 comma 1 it has now shifted to minus 1 1. Okay, so these are the three coordinates which you will be getting. So 1 comma 0 is shifted to 0 comma 1, 0 comma 0 is shifted to 0 comma 0 only, and 1 comma 1 is shifted to minus 1 1. So if I try to plot it here in this particular case, the same tabulation I'll do it. So just extend this line, so this will be minus 1 and this will be minus 2. So first point remains as it is 0 comma 0. The second point will be 0 comma 1. Okay, the second point will come here, it is 0 comma 1. The third will come as minus 1 1. So minus 1 is here and 1 is here. So what will the figure looks like? It looks like this. Okay, if it is rotated by 90 degree, so first is 0 comma 0, we will be getting 0 comma 0. The second point is 0 comma 1. 0 comma 1 is this, so this will be 0 comma 1, and this is minus 1 1. The figure looks like this when you rotate it by 90 degree. Okay, when rotated by 90 degree, so this is when I do it by anti-clockwise direction. Okay, we'll solve the same problem if I rotate it by clockwise direction. The same problem if I rotate it by clockwise direction, we'll see what will happen. So I hope it is clear in the case of anti-clockwise. So same problem we'll be doing in a clockwise direction. If I rotate it by an angle 90 degree clockwise direction, so the same problem, once again we'll draw it. Okay, so So this is the origin, 0 comma 0. I'll take 1 unit, 2 unit, 3 unit, 1 unit, 2 unit, and 3 unit. Okay, so if this is the figure, so first we'll locate the points. One is at 0 comma 0, second is at 1 comma 0, so this is the point. The third one is 1 comma 1. So this is the triangle, initial triangle before rotation. Okay, so before rotation it looks like this. So we have to rotate it by clockwise direction 90 degree. So if I want to rotate it by clockwise direction, and it is by 90 degree. Okay, so what will be the points? Okay, so we'll start with this. So we have the formula already here at the top. So if I want to do the clockwise rotation, so this is for 0 comma 0. Okay, so x dash y dash will be, so cos 90 as usual, 0 1 minus 1 0, and the coordinates are 0 0. So if you see, there is no change here. X dash y dash will be 0 comma 0. X dash y dash will be 0 comma 0. So the change, if you see, from 0 comma 0, it has taken to 0 comma 0. Original position and new positions are same for this particular point. Okay, if I go with the second point, that is the 1 comma 0. 1 comma 0. If I go with this particular point, so x dash y dash will be equal to, so the matrix is 0 1 minus 1 0, and the ordinates are 1 and 0. Okay, so what you will get? So x dash y dash will be 0 into 0 is 0, 1 into 0 is 0. So first x coordinate remains as it is. Minus 1 into 1 is minus 1, and 0 into 0 is 0. So you will be getting this coordinate. So 1 comma 0 now is being shifted to 0 comma 1. It is being now shifted to 0 comma 1. That is the second point. So the third will be 1 comma 1. So 1 comma 1. So once again we will go with x dash y dash. So here 0 1 minus 1 0 should be multiplied by 1 and 1, 1 and 1. So if you do that, what you will get? 0 into 0 0, 1 into 1 is 1. So you will be getting x dash y dash as first x coordinate as 1, minus 1 into 1 is minus 1, 0 into 1 is 0, so you will be getting it as minus 1. So 1 comma 1 is being now repositioned to 1 comma minus 1. Okay, I hope it is clear. So if I try to locate it on this particular case, so we'll just extend this, because y coordinate is negative here. This is minus 1, minus 2, and minus 3. Okay, so if I see this, first is 0 comma 0, so it remains as it is here only. Okay, the next coordinate is 0 minus 1, so it comes here. Okay, 0 minus 1. The third will be 1 minus 1, 1 minus 1. So here 1 is there and here minus 1 is there. You will be getting this point. So the triangle looks like okay. So this is the before rotation, and this looks after rotation. Okay, so I hope this is clear about the rotation operation, how the rotation operation is done, and how we need to uh, use the formulas to just formulate the new position of the points. So whenever the rotation happens for a particular object, so how many points are there, based on those points we need to just orient them based on the formulas given. The important parameter here is you have to check the direction of rotation, whether it is a clockwise rotation or whether it is an anti-clockwise rotation. So based on this you need to apply these two formulas. There are two different formulas for clockwise and anti-clockwise rotation. Okay, so next we will be moving ahead with the new operation which we call it as scaling. Okay, so the new operation now is scaling. So you know that what is the scaling operation? Okay, if I still rub it. Okay, we know that. What do you mean by a scaling? Scaling means we will be resizing the object. Resizing. Okay, so we have seen a scaling. Basically when we are drawing, we used to, depending upon the dimensions, we used to scale the component. Whether if it is a bigger component, we used to scale it to 1:2, which whenever we used to do 1:2, so the scaling will be 1/2. So it will be equal to 0.5. The scaling ratio will be 0.5. So if a component is very small, we in order to visualize it, we used to do it as 2:1. Okay, so which means that the scaling ratio is 2. So sometimes if the component is exactly with the representation, when we used to do it as 1:1, which is exactly to the scale we are doing it. Whatever the dimensions are given, exactly to the dimensions we will be scaling it. So scaling is an important parameter where we are enlarging or reducing the size of an particular object. So how the scaling works? So scaling can be done in both the axis. So whether we are doing the scaling along x-axis, whether we are scaling along y-axis. So if I have a particular object, so I want to scale it to make it a bigger object. So this is enlarging. Okay, or whether I want to make it a very small object, it is decreasing the size. So basically scaling, in order to do the scaling we require the ordinates. So how much you are doing the scaling. So if I take the x dash coordinate, there will be a parameter called as scaling along x axis. We will be representing it as sx. Sx into, this is a scaling parameter, whether we want to increase the size or whether we want to decrease the size. So sx into the original coordinate, whatever the original position is there. So y dash will be same as sy into y. Okay, so here sx and sy are the scaling parameters. Scaling parameter. See, it is very simple. If I want to double it, I have to multiply that doubling factor. That is, whether I want to double the size along x-axis, whether I want to double the size along y-axis, I need to just apply it with respect to the coordinate system. Okay, so if I want to write the same thing in the matrix form, how can I write it? As it is a multiplication factor. Okay, it is a multiplication factor, x dash y dash. So I have to write it sx 0 0 sy, because here it is a column matrix. So here it becomes x into y, x into y. See here, if you just see this, sx into x, 0 into y will be same as sx into x. Okay, so here sx and sy are sizing factors or scaling factors. Okay, so there are, you can just understand how the things are done, and we'll be solving a problem on this, so that you will be much clear about this particular operation. So it is just nothing but increasing or decreasing the size of a particular component. So if you see these things, there will be three cases. One is, the first case will be if sx and sy, okay, are less than 1. Okay, are less than 1. Less than 1 means, if I have already told you, if less than 1 means half, if I take, okay, it will be 0.5. So what exactly happens here is, the size reduces. Size of the object, size of the object reduces. Size of the object reduces. So next will be second case. If sx and sy are greater than 1, what exactly happens is, if I take 2:1, same thing, so it will be 2. Okay, the size is doubled. Okay, the size of the object increases. Okay, so these are the two cases. So the third will be, if sx comma sy is equal to 1, so there will be no change in the size. No change in the size. Okay, so you can just apply here. What will happen if sx is greater than 1? What will happen if the sx is less than 1? What will happen if sx is equal to 1, or sx or sy if it is equal to 1? So based on this, we will be doing a scaling of any object. Okay, so in order to get the new coordinates, we will be using this as our equation to get the new coordinate of a particular equation. So we will be doing the same thing. We will be doing two cases. If the scaling size is big, if the scaling size is less, the two cases we will be solving here. We will take an example for this, so that it will be much clear. So we will take the same square which we have done for the translation. Okay. So we'll take a square. We'll write it as resize the given square with coordinates 0, 0, okay, 2, 0, 0, 2, and 2, 2, okay, where I'll take sx, which is scaling along x-axis, is 2, and sy scaling along y-axis is 3. So if you see this particular scaling parameters, sx and sy are greater than 1. Sx and sy are greater than 1. So of course the size of the square object should be big compared to the original position. Okay, so we'll try this. First we'll write the original position of the given object. So what will be the original position of the given object? So first we'll write down the coordinate system. So this is the origin along the x-axis, along y-axis. So this is 0, 0, and this is first unit, second unit, third unit. So this will be first, this will be second, this will be third. Okay, so first coordinate is 0, 0, so I'll write it here. Next is 2, 0, I'll write it here. Next is 0, 2, I'll point it out. Next is 2, 2, so this will be coming here. So if I draw this, this is the original square object. This is the original square object. Okay, so I need to scale it by 2 units in x-axis and 3 units in y-axis. So we'll start with the solution and later we'll draw the coordinates of this, so how it looks when it is resized. So next is first is the point 0, 0. The first point is 0, 0. So x dash y dash will be having, and if you see the formula, it is Sx 0, 0 Sy. So Sx is given as 2, 0, 0, 3. So this is the equation which we will be writing, and original coordinate system. So 0, 0. Okay. So if you see that the x dash y dash will be 0, 0. Okay. So origin has not changed. Okay. Only the other points are changed. So here equal to, if you see 0, 0, so 0, 0 has now changed to only 0, 0. Okay. So next comes the point 2, 0. 2, 0. So we'll be doing that. X dash y dash will be equal to 2, 0, 0, 3, and the ordinates are 2 and 0. Okay, so what will be the equation? 2 2s are 4 and 0, 0, 0. So your answer will be 4, 0. So x dash y dash will be 4, 0. Now 2, 0 is being changed to 4, 0. Clear? So this is the second point. So when we go with the third point, so the third point is 0, 2. So third point is 0, 2. So x dash y dash will be Sx is 2, Sy is 3. Okay. So we will be writing the coordinates 0 and 2. Okay. So when we do this, what we'll get? 2 zeros are 0, 0 2s are 0, 0 zeros are 0, 3 2s are 6. So the ordinates are 0, 6. So x dash y dash is 0, 6. Now what has happened? So 0, 2 original position is being shifted to 0, 6. Is it clear? So we need to just watch how the change is been taking place. So we'll be doing this. So next is the last point 2, 2. So 2, 2, which is x dash y dash. So if I go with this, it is 2, 0, 0, 3, and the shift is 2 and 2. The original positions are 2 and 2. So if I do this, 2 2s are 4, it is 0, and 3 2s are 6. So what will get? 4, 6. So x dash y dash is 4, 6. Now what has happened? 2, 2 is being shifted to 4, 6. Okay, 4, 6. So we'll try to plot this on the same coordinates. Okay, so I'll just enlarge this. This is 4, this is 5, and this is 6. Okay, this will be a rough one. This is 4, this is 5. Just extend this. this will be 6. Okay, we'll try to relocate the points, the new coordinates. First will be at the origin only, 0, 0. The second will be at 4, 0. So the second point will be at 4, 0. The third will be at 0, 6. 0, 6. The fourth will be at 4, 6. 4, 6. Okay. So if I try to draw this will be the new square. The new square which is been enlarged. Along x-axis by 2 units and along y-axis by 3 units. So this will be 4, 6. This will be 4, 0, and this will be 0, 6. Okay, I hope it is clear. We have done the operations here by considering all the 4 points. Origin remains as it is, one of the points. So the other points have been shifted, and you can see how the scaling of an object takes place here. Okay, it's a very interesting problem. So if you can just go through this, it will be better. So you can see all the steps how it has been proceeded here. So we'll take the same problem. If the same square is, I'll try to reduce it. The scaling, I'll try to reduce it. So I'll take the scaling factor as 0.5, 0.5. So this is 0.5 and this is 0.5. Okay, so what we'll do is we'll draw once again the coordinates, same square only. We'll try to reduce it. Okay, so this is the origin. So this is x and this is y. So I'll take this a bigger one. 1, 2, 1, 2. Okay, first point is 0, 0. Second is 2, 0. Third is 0, 2. And this is 2, 2. So this is an original square. This is an original square. We can get okay, this is an original square. So we'll try to apply the scaling factor of 0.5 and 0.5. So we'll try to apply the scaling factor of 0.5 and 0.5, and we'll try to see how there is a change in the shape of the component. Okay. So first point is once again a 0, 0. So we'll try to get the new coordinates x dash, y dash. So it is fx 0, 0, sy. So it will be 0.5, 0.5, 0, 0, 0.5, and the coordinates are 0, 0. As the coordinates are 0, 0, so answer will be x dash, y dash is 0, 0. We can see that. So what is the change here? So original coordinates was 0, 0. You got it as 0, 0. Okay, this is for the first point. Next we'll go with the second point. The second point comes as 2, 0. 2, 0. So x dash, y dash will be 0.5, 0, 0, 0.5. Okay, so the coordinates are 2 and 0. So 0.5 into 2 is 1, 0 into 0 is 0. So what is the coordinates you will get? X dash y dash will be equal to 1 comma 0. Just check. 0.5 into 2 is 1, 0 into 0 is 0, 0 into 2 is 0, 0.5 into 0 is 0. So this is the new coordinate. So if you compare the original coordinates with the new coordinate, so there is a reduction in the coordinate. So 2 comma 0 is now converted into 1 comma 0. So same way, if I go with the third point, so third point is 0 comma 2, 0 comma 2. So we'll go with that. So x dash y dash will be equal to 0.5, 0, 0, 0.5. So and the ordinates are 0 and 2. Okay. So if I calculate that, what I'll get, x dash y dash will be equal to 0 comma 1, 0 comma 1. So just go through that, 0 comma 1. So next comes the parameter 2 comma 2. The coordinate is 2 comma 2. So we'll calculate the next one, x dash y dash will be equal to 0.5, 0, 0, 0.5 into 0 and 2 and 2, 2 and 2. So if you do it, what is the ordinates you will get? X dash y dash will be equal to 1 comma 1. So x dash y dash will be equal to 1 comma 1. So you can just see here what is the change. So the change was here 0 comma 2 2, 0 comma 1, and here 2 comma 2 2, 1 comma 1, 1 comma 1. So you have to just see the coordinates here, and we'll be plotting it on the coordinate axis here, which we have done previously. And this is okay. So we'll be plotting it. So first point is 0 comma 0. It will remain as it is here. The second point is 1 comma 0. So we'll be getting it as here. The point is here. So the third point is 0 comma 1. We'll be getting here, and the fourth point is 1 comma 1. So we'll be getting it as here. Okay, so you can see here there is a reduction in the size of the square object. So initially it was 2 by 2, now it has been reduced to 1 by 1. So this is the original square, and this is the reduced square. When you apply, Sx is equal to 0.5 and Sy is equal to 0. Clear? So this is about scaling. So you need to understand what exactly is happening in the scaling. We are enlarging or reducing the size of the object. Okay. So I hope this is clear about the scaling. So next we will be going with the concept called as sharing. Okay, sharing. What exactly a sharing means? So if I want to distort any particular shape, okay, for example, if I take a square, okay, I want to distort it in particular this x-axis. So what I'll do is, if I apply some sharing command, so I'll be distorting in this particular case, like this. So if this is a see what I have done exactly here is, it is the original position. I have tried to distort this along x-axis. So if I draw the axis here, okay, I'll try to distort it along x-axis. What exactly is happening here is, if I have a square with certain coordinate system, so I want to change the shape of this particular square on a particular axis. So there are two particular axes here, x and y. So when I try to distort this particular square in x-axis, I'll call it as x share. If the same component, if I want to distort it in y-axis, so y-axis means what I'll do is, I'll try to distort it in a particular y-axis. I'll try to distort somewhat. I'll try to distort in this particular fashion. Okay. So what exactly is happening here is, if you see this x share, x share means distorting a particular component in x-axis. This is a component. What exactly I'm doing is, I'm trying to hold the y coordinates as it is and trying to change the x coordinates. See, if you see this particularly, so if this was a component, now it has been shifted to the new position. New position means it is just, I'm trying to distort the face of that particular shape of that particular square in an x-axis manner. When I'm doing this, y coordinates remains as it is. So you can just observe here, y coordinates are not changing anyhow, but the x coordinates are shifting. So this is called as x share. In the y share, the x components remains as it is, y coordinates will be just distorting or just changing the position. So that is the difference between an x share and a y share. So how we will be writing the coordinates for formulas for this, or for the new position, what we will be writing is, as I already told you, whenever an x share happens, y coordinates remains as it is. See, if you can just observe, y coordinates remains as it is, only x is changing. So the new position of y will be as it is to the original position. The new position of the y will be same as the original position, but there is a change in the x, that is the new position of x coordinate. So how the things are written is, that will be the original, this will be the original, and how much the share has taken place. So it will be a parameter called as shx into y. Okay, you have to remember this. This will be shx into y. Okay, so shx is a sharing parameter here, and y is the ordinate of that particular component. So similarly, you have to remember this. If an x share happens, y coordinate remains as it is. X will be changing with x original plus sharing parameter. Okay, so y share means, if I am holding x-axis as it is and changing the y coordinates, I am trying to distort the y coordinates. You will be observing when we are trying to solve these particular problems. We will be solving some of the problems when we are doing an x share and y share. We will be seeing what is the change in the shape of a component. Okay, so in an y share, I have told you that x coordinate remains as it is. So y coordinates will be y plus shy into x. So you need to remember these two equations whenever we are doing a sharing operations. So sharing is nothing but distorting a particular object in a particular axis, whether it is an x-axis or y-axis. Depending upon the axis, we are having x share and Y share. I have given you a demonstration about how exactly an X share happens. So Y coordinates are as it is in their position, only the X is getting only X is getting changed. Based on that, we call this as an X share. So if X coordinates remains as it is and Y coordinates goes on changing, we call it as a Y share, and based on that logic we are written the formulas. You have to remember these two formulas whenever we are doing a sharing operation. So in the next class we will be using these formulas and we'll be trying to solve the problems on sharing. Okay, so thank you.